This is Unit 4, review number 2. This is technically 4.9 on my website. All right, so problem number 1 here. You are asked to graph this based off some information. So first I have to find the information. So when I go through and solve this one, I'm going to take the derivative first. That's going to give me 3x squared minus 2x minus 1. You take that derivative, 3x squared minus 2x minus 1, and you set that equal to 0. We're doing that because we're trying to find our mins and maxes. This is going to factor into 3x plus 1, x minus 1, and when you set those equal to 0, you're going to get x is equal to a negative 1/3 and a positive 1. So they are my critical values. Again, whatever you set the derivative equal to 0, the answers you get, they are your critical values. They are where your possible mins and maxes are, which are your extreme values, which are down here. All right, so to determine all that, what we normally do is we draw the number line out, okay, and this is going to help us find out where it's increasing and decreasing. So negative 1/3 and 1, these are those numbers, those critical values. I put them on the number line, and I choose numbers to the left, in the middle, and then to the right. And when I do that, I'm going to find out that it comes out as a positive to the left, it is a negative in the middle, and it is a positive to the right. So it's going to be increasing from negative infinity to negative 1/3. It's going to then be decreasing from negative 1/3 all the way to positive 1, at which point it then starts to increase again from 1 to infinity. Remember, we use parentheses because it's not increasing or decreasing at negative 1/3 or 1. All right, so what I normally like to do is I draw in my little slash marks here. It shows it's going up, it's coming down, it's going up. So this is going to be a maximum at negative 1/3 and a minimum at 1. All right, now technically, we have to check to make sure we don't have a point of inflection that trumps that, so I'll do that right now. So f double prime of x, this is my second derivative now, is going to be 6x minus 2. I take that 6x minus 2 and I set that equal to 0, so 6x minus 2 equals 0. You get x is equal to a positive 1/3. So close, but it's not the same. So the critical value over here is 1/3. I do the same thing. I draw my number line, I have my 1/3. And I'm going to find a number to the left and to the right of that and plug it into my second derivative so I can find out whether it's concave up or concave down. So the number I'm going to choose to the left is 0. You take it, plug it in, you're going to get a negative number. And then to the right, to say 1, you plug it in, you get a positive. So that tells me it is concave down from negative infinity all the way to 1/3. And then from 1/3 to infinity, it is concave up. We're getting that from the positive and the negative. All right, so points of inflection. Again, any critical values you have for your second derivative are going to become points of inflection. So your 1/3, you're going to take that, plug that back into the original now. Now my goal is to graph this. To graph it, you need points. That's x comma y. So you need my y value at 1/3. Take the 1/3, plug it into the original. Again, I could recommend you doing that on the calculator. Make the calculator do the work. You get 2.593 for the y value. All right, going back over here then for our extreme values, our mins and our maxes, at negative 1/3, when I plug in negative 1/3 into, again, the original function, I'm going to get 3.185. We already talked about that. That's going to be a maximum. This is going to be a relative max. Remember, you're not going to have an absolute min or max when it's an x to the third. You're going to have an absolute min or max only if it's an x to the fourth or x squared, an even degree polynomial. Our last one here is going to be a 1. You take 1, you plug it in, you get 2. A little bit nicer of numbers, and that's going to be a relative min. So my last step is to actually go through and graph this now. So when I do so, I have a relative min here at 1, 2. And I have a max at negative 1/3, 3. So we'll plot those. And then we also have this 1/3, 2.59 for our point of inflection. I typically do the point of inflections first, so 1/3, 2.5 is going to put me somewhere in there. Negative 1/3, 3.18 is going to give me a number right around there, and then 1, 2 is going to be right here. All right, so when I go through and do this, again, this is going to be a shallow graph. What we have is concave up the second half, so this is concave up, again, hitting that minimum we have there, and it's concave down over here. Okay. And we have it coming through our x-axis, and that is your graph. That is complete.